Where'd you go, number one?
Can you just work on and help? Because I didn't know where to start.
Okay, well, this says what? The third term in the sequence is negative 30. So this is the third term, so we don't know 1, we don't know 2, that's 3. We know the sixth term is negative 6. So that's the fourth term, I don't know. The fifth term, I don't know. The sixth term is negative 6. Find a common difference. So the key is it tells me it's an arithmetic sequence, which means we are adding or subtracting the same number over and over and over. So in total, how much did I grow to get from negative 30 to negative 6? How much have I went up in total? 24. And so if I had to divide that equally, so I'm adding the same thing every time. If I went up by 8, that would put me at negative 22. And if I went up by 8, that would put me at negative 14. And if I went up by 8, that would put me at negative 6. We follow that? So what's the common difference? 8. Easier way you could do it. We talked about this is very close to like a linear. Right? Think about this as the slope formula. You don't have to do it that way, but you can. Right here, this is y2 and x2. So negative 30 and 3. And then here would be your y1 and x1. So minus negative 6, minus 6. So that's negative 24 divided by negative 3, which is 8. It's the common difference. You could also have used that big, ugly formula that they gave us. The a sub n equals a sub k times d. Times, and then, is it n minus k or k minus n? N minus k. I'm looking at it right here. You want me to show you how to do it that way? Let me show you all the different ways? No? Okay, cool. It was a really hard one, wasn't it? It's difficult. 2.
Are you patient on this?
A little. The seventh term of an arithmetic sequence is 18. And the common difference is negative 5. Write a rule for the nth term. Oh my God. So we had a formula. A sub n equals a sub k. So does this mean that, like, when y'all look at formulas, like, none of it makes any sense to you? Is that what this is boiling down to? So a sub n, that represents any term in the sequence. So we're writing a rule in terms of a sub n. So we leave that equals a sub k. That could be any term. In this case, the only term I know is the seventh term is 18. So my a sub k is 18. Plus, what's the common difference? So negative 5 times n. N is whatever I want it to be. Minus k. So what's the term that I knew in the sequence? I knew the seventh term, so k should be 7. That's it. Talk to me. Great. Okay. Is it understandable? Okay.
Are we going to learn about geometry?
That's today. Three. The graph of the sequence is shown. Is this sequence arithmetic? Why?
Common.
Yeah, it has a common difference. What is the common difference? 4. That's what you could say. Yes, there's a common difference of 4. And when I look at all those points, they appear to be in a line. And arithmetic sequences look linear. I don't want to write all that. B, write an expression for a sub n, the nth term in the sequence.
You would just put the point on there.
Uh-huh.
Okay, I didn't. I don't say.
Let's hear it.
A sub n equals -6 plus 4. N minus 1 equals 6.
Negative 6 plus 4 times n minus 1. That's it. Because here you chose the first term. Its value was 6, or negative 6, sorry. So you plug in negative 6 as your a sub k, plus the common difference was 4 times n minus, that was the first term in the sequence, n minus 1. Not sensing a lot of positivity, not a lot of confidence. You think you got it? Okay. Okay, yeah. Cool. 4. Mario sets his cruise control at 68 miles per hour. Is the function that represents his total distance driven after n hours an example of an arithmetic sequence? Why or why not?
Yeah.
Why not?
Because it would just be.
He like increases to 68 and then he sets it on cruise control so he doesn't go any faster.
Okay, but we're not talking about speed anymore.
He would.
We're talking about distance and
Every hour he would go up.
Time.
68 miles.
so let's try to make a sequence and see if it makes sense to us. After 1 hour, he would have driven 68 miles. After 2 hours, he would have driven 136 miles. After 3 hours, he would have driven 204 miles. So checking my math. After 4 hours, he would have driven 272 miles. After 5 hours, 683.40. Is this an arithmetic sequence? No.
No.
Yeah, why?
Because he has to get up to 68 miles per hour. Or 6, whatever.
It has nothing to do with speed.
How is it?
We're looking at distance and time. It's what I made an arithmetic sequence. Yes, what I made is an arithmetic sequence. Is this valid for this situation?
No.
Why not? Don't say speed.
Excuse me, teachers. I know we have several substitutes here today, so if you could please write down your absences on a little piece of paper and send them to the high school office with a student, that would be great. And if you don't have a role, if you will call me, I will try to get you one. Thank you.
So what I made is an arithmetic sequence. I made one of the situation. But this is not valid because what is this representing? This is the number of hours driven. Is this the only elements possible in the domain? Can you only drive 1 hour or 2 hours or 3 hours or 4 hours or 5 hours? It's not discrete. The number of hours driven is not, I can't count every value possible. It's a continuous function because the number of hours driven could be a half an hour or a quarter of an hour or 0.37 of an hour or 2.5 hours. So the domain is not this. The domain includes values between those that I'm having to leave out. Therefore, it's not an arithmetic sequence. To be an arithmetic sequence, the domain must be, like look at the graph right above it. Look at the x values, 1, 2, 3, 4, 5. So when I say discrete and continuous, do you guys know the difference there? I think we talked about it. Maybe it was in Algebra 1 I talked about it. Continuous means all these dots are connected. So when I'm driving, I'm connected between the dots. What's an example of something that's discrete? Say I'm buying bars of soap and they cost $4 each. I don't know. So if I buy 1 bar of soap, I spend $4. 2 bars of soap is $8. 3 bars of soap is $12. Is that an arithmetic sequence? Yes. Can I buy 2.5 bars of soap? 1.25 bars of soap? The numbers between don't make sense. That's discrete, countable. Right? Both those words are used interchangeably. Or finite is another word. You guys know what finite means? Finite, listable, countable, discrete. So all used interchangeably. On the flip side, the number of hours driven. If I drive 1 hour, it's 68 miles. If I drive 2 hours, it's 136 miles. 3 hours is 204 miles. So on. But could I pick values between there? Could I drive 1.5 hours? 2.5 hours? 2.25 hours? 7.6 hours? There are 15 tiles on the path from Little Red Riding Hood's house to her grandmother's house. Don't go. There's a big bad wolf. On the first tile, Little Red drops 2 crumbs of bread. On the second tile, Little Red drops 6 crumbs of bread. On the third tile, she drops 18 crumbs of bread. On the fourth tile, 54, and so on. Describe the pattern in the number of crumbs she drops on each tile. A little bit more specific than that. You're not wrong. Each value multiplies by 3. But where do we start? You've got to give that initial value too.
Start at 2.
So 2 on the first tile. Then the number of crumbs triples. Anything here? Questions? 2, complete the table to show the number of crumbs dropped on each tile of the first 6 tiles. Write each term using only 3s and 2s. So how many was on the first tile? 2. How many was on the second tile? There we go. How many was on the third tile?
2 times 3 times 3.
Uh-huh. And on the fourth tile?
2 times 3 times
And on the 5th tile. And the 6th tile. So what's happening each time? We're multiplying by 3 and multiplying by 3 and multiplying by 3. You see how this is similar? Like this is a sequence, but it's not arithmetic because we're not adding the same thing each time. We are multiplying the same thing each time. So we don't have a common difference. We have what's called a common ratio. Did I kill it? I don't think I did. In this case, that ratio is R equals 3. And then what's the first term in my sequence? And I'm just going to switch to their notation because that's what they use. Instead of using A naught, I'm just going to use A sub 1. So the first value is 2, and then they have a common ratio of 3. So what's another way we could write this more simply than having to keep writing times 3 times 3 times 3? Exponents, absolutely. So when there was 1 tile, how many crumbs were there? There were 2. What about when there were 2 tiles? It was 2 times 3 to the first. What about when there were 3 tiles? And when there's 4 tiles? Can y'all see that color? No. And when there was 5 tiles? All right, so how could I make this look more similar? Because, like, when I look up there at 1 tile, it kind of doesn't fit in. That's it. Yeah, to the 0. So just using our table of values, how many crumbs will she drop on the 8th tile? I don't want that. How did you find that number? That's it. 2 times 3 to the 7th. Does everybody follow how we would get there? By looking at the table, hopefully. And that is 4,374 crumbs. It'd take a lot of time.
Oh, she's purposefully dropping the crumbs.
Yeah.
Oh, okay, I got you. I thought she was just
Little Red drops 1,062,882 crumbs on the 13th tile. How many will she drop on the 15th tile?
I'm gonna say this. Is that 95,659,000? Nope. There's not any commas.
9,565,938 crumbs. How did you come up with your answer? So you did 2 times 3 to the 12th? To the 14th? Okay, that's one way. Using the information that you were given, what's another way you might could do this? Using that information. I'm not, there's nothing wrong with what you did. But they have, so you could take the number you were given for the 13th tile, multiply by 3 squared, or times 9. Does that make sense to everyone? Because it's 2 terms away, so it's tripled twice. So times 3 squared. How many crumbs will she drop on the nth tile? Here's what's going to fall apart. I just know it. I just know.
times 3 to the n minus 1.
Yeah! 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 Formula! Look at that. Okay. 2 times 3 to the n minus 1. Is that growth? Like, does that formula like scare you because it has like a variable in it and you made it? Or, I mean, that's growth, right? Y'all were scared to death doing the check your progress just a second ago. Okay, still won't talk to me. Fine, cool. I'm trying. I'm trying to pump you up. I'm trying to be excited. You guys, no, never mind. I'm not going to say it. 7.
If there's more than
Oh,
one
I'm very much
7. The 7th tile marks the halfway point to Grandma's house. How many crumbs did she drop on the 7th tile? That's how many? 1,458 crumbs. So this was the halfway point. So remember yesterday with the arithmetic sequence? Yeah, remember how we found the average was the middle term? Because it was... So Kenny thinks we should multiply this average amount, because it's the middle, multiply it by 15 to determine the total number of crumbs dropped. Will this strategy work? No. No, it doesn't. Why doesn't it work? That's it. The change in the number of crumbs from one tile to the next is not constant. It's not something I add the same thing each time to. Right? I multiply the same thing each time. So the sum will definitely be bigger than what Kenny thinks. And you could have kind of figured that out already from the information you knew. This is about 1,500 crumbs. So like in my head real quick, if I did 1,500 times 15, that would be 15,000, and then it would be 7,000. So 22,500 is about what Kenny is estimating. Well, we know how many crumbs did she leave on the 13th tile already? 1,000,000. So if the average in total was going to be about 20 something, what did I say? I can't remember what I said. 15 and 22,000, according to Kenny. Am I just losing y'all? I'll just quit talking. Okay,
No, you're not losing us. We're losing them.
that's fine. I won't say words.
No.
Like, I know, I do the mental math, and I think I just lose y'all. Like, you're like, I don't know.
No, we're listening. We don't want to interrupt you. You want us to like say yes every time?
Or like a head nod, or like, oh, or like, a thought of, yes, I follow. Instead, it's shut up. That's the look I get when I look up there.
Yes, I follow.
You can't
Good.
lose out on us right now.
I can't what?
You can't quit on us right now.
I'm not quitting on you.
Good.
I'm quitting on geometric sequences. Okay,